biology, and welcome to a video going over the homework. We're first going to talk about the lab that you're going to be working on next week in terms of a write-up. We're going to be assessing your ability to use mathematical thinking to analyze data, but this is going to involve you using that mathematical thinking within two argumentative claims. Now, your homework for class on Monday or Tuesday is to take these data tables, add some columns for extra data sets, and to calculate average slope, standard deviation range, the standard deviation range, the SD range for controls, maybe types of high yeast or low yeast or high sugar or low sugar environments, to then talk about data trials that you think are incredible and terrible. You're then going to delete those terrible trials and then recalculate those computations you did in data table 3. So data table 3 and data table 1 should look identical. The only difference being is that these numbers should be more precise and or more accurate. So what to do about that? I think the first thing that you want to make sure you feel good about before you do this is how you can understand R2, which is the goodness of fit. How well does a data point fit within a trend line that we observe? And then RISME, which is how accurate and how precise is that data. Again, these two sets of data have identical R2s, but this RIMSE is a lot higher because many of the data points, whether they're really high or really low, are not well predicted. We talked about the 3 reasons why you might get rid of data, including similar trials have different R2 values. Identical trials with identical R2 values have different RIMSEs, and also some data looks a little suspicious based on temperature or CO2 measurements. So let's go into the data. I've organized the data based on 3 different groups. The first group is going to be high sugar. So for example, this value is basically saying for every gram of yeast, we had 6 grams of sugar. Here is our control, and here is our high yeast environments where the ratios get above 0.5. Now, in terms of computations, here are the computations that you can use. We can calculate average, standard deviation, and range. So I'm just going to type in here, average, standard deviation, and range. Okay, every time you do a computation, you always start off with equals. You're going to then press left, or you're going to then type in what you want to solve. So I'm going to type in average, and then I'm going to highlight this, and I'm going to press right parenthesis. I'm not going to do autofill because I don't want that. I want to calculate other things, but this is basically saying my range of the control was 5.9 CO2 per second. Standard deviation is STDEV. I'm going to highlight the data, do a right parenthesis, press enter. 7.42 is the standard deviation. And then finally, I can do range, which is going to be equals max. Highlight this data. Right parenthesis minus min. Highlight the data. Again, I have these here so you can see the computation for average, the computation for standard deviation, and then finally the computation for max and min. So if you look at this data, I have a range of 5.9085, a standard deviation of 7.42. That's suspiciously high, and also a range of 29. Now, if you look at this data, there should be some very suspicious ones. For example, this row, 30.825, correlation is 95%. That seems pretty low, and a RIMSE of 749. So in your Google Docs, you might list in table 2 that number control number 25, because this is row 25, with GJTH is suspicious because of its high slope, which is very high compared to the others, a low correlation, and a really high RIMZ. So you're going to be able to delete that. If you keep your computations here, these should automatically update, so you'll be able to then just put those new numbers in the third table. I go back. I notice that right below it is 232. Again, suspiciously high value compared to the others, which all seem to be in sort of the 1 to 2 category. RIMZ is in the 200s. That's not good. Delete. Again, these computations, when you're finished deleting, will be what you put into table 3. So that is the homework in a nutshell. You're going to be organizing your data, calculating average, standard deviation, and range for your 3 groups, talking about data that you think is really bad or really good, taking these really bad data sets and deleting them from your tables, and recalculating average, standard deviation, range. From that, you should be able to make the standard deviation range, which is always 2 times the standard deviation up and down, and also divide the standard deviation by the average. We'll go over these. Well, all of you might have very different results, but we will go over this on Monday and Tuesday if you have questions before the lab. My only last piece of advice is you can be a little creative. And what I mean by creative is you might organize this high yeast ratio into ratios that go to maybe 1.5, and then another set of data that goes from 2 to 11. Use your imagination with how you want to organize these data sets into different mountains, so to speak. I hope this video has been helpful, and I will see you guys Monday and Tuesday. Take care.